Hello everybody, we're going to take a look at prime factorization this time. We're at WAMAP and we're looking at 2.1c, so this is unit 2 for Math 53, prime factorization. And our two problems here are find the prime factorization of 900 and find the prime factorization of 1512. So if you are struggling with this, you can take this 2.1c and go back to Canvas and search through 2.1c and make sure your page is up to date. Let's see, search for 2.1c. And here it is. So this is one way to try to solve your problems. I will be making videos and modules for all of the problems in Unit 2. So that may be your first line of defense. So I have a screenshot of the problem and a video. There'll be a video here and a screenshot of what your worksheet should look like. And then there are more practice problems here. And they use a prime factor tree, and I'll show you how to do that now. And then, of course, the GED formula sheet's also available. And links to Khan Academy and another language. So you can go ahead and try those links. But let's go ahead and take a look at the tablet and see how it looks. So we're going to find the prime factorization of 900. And I wrote out the first 6 prime numbers here, and so you should have those from the previous exercise, and you should be able to recite or figure out the first, say, 9 or 10 prime numbers, because these are the ones you're going to use mostly when you factor numbers down. So I always like to start with the lowest number, and these numbers are both divisible by 2. We know that from our divisibility rules. These are both even numbers. So to do the factor tree method, we just branch out from there, and we're going to have our prime numbers we'll put down on the left side of each branch, and then on the right side we'll put the remainder. So 900 divided by 2 is 450. That's another even number, so we'll divide that by 2 and get 225, and that's not divisible by 2 anymore. You could divide it by 3, but I'm going to go with 5 because that's jumping out at me. That's obvious that way. And that's 45. And then 45 is also divisible by 5. It goes 9 times. So that should be coming to you pretty quickly with your multiplication table. And then 9 is divisible by 3 twice. So our prime factorization of 900 is 2 to the second power times 5 to the second power times 3 to the second power. And this, I've said before, this is like a zip code. It only points to 900, and 900 always factors down to this exact prime factorization. And because prime numbers can't be reduced by any other factors, this is the set of numbers that can produce 900, and it can also reveal some mathematical qualities about this number, and we'll learn about that in the next lesson when we are looking for least common denominator, the least common multiple, and the greatest common factor. So those will be coming up soon, so stay tuned. Anyway, the answer we would put in at WAMAP is 2. Let's go over here. I'm sure we can get there. Okay, so 500, here we've got 2 and then caret, so uppercase shift 6 and then a 2, and step to the right with the arrow key and then an asterisk, which is shift 8, and then 5, shift 6, 2, step to the right with the arrow key and an asterisk, and then 3, shift 6, and 2. So this should be the prime factorization of 900. And some people might be nitpicky and say it should be 2 squared times 3 squared times 5 squared, but we just ended up getting it this way, so we're going to submit it that way. And if WAMAP says it's okay, then we're okay too. So it was accepted. That's correct. And let's look at the prime factorization of 1,512. If I can get there. Here we go. So this is an even number, so we're going to divide it by 2. And that's 750 plus 6, 756, right? And that's also an even number, so we can divide that by 2. And 750 divided by 2 is 375, plus 3 for half of 6 is 378. And that's another even number, so let's divide by 2. And we'll get 37 divided by 2 is 18. And then we've got 18 divided by 2 is 9, so 189. And this is no longer divisible by 2, right? Because it's now an odd number. But if we add these up, 1 plus 8 plus 9 is 18, which is divisible by 3, so let's go with that. 18 divided by 3 is 6, 9 divided by 3 is 3. So 63, we can keep going with 3's. 3 goes into 6 twice, and 3 goes into 3 once, so 21, and then 3 and 7. And we now have nothing but prime numbers here. So we have prime factorization 2 cubed, right? 2 to the third power times 3 to the third power times 7. And in the same way, this is it's like a zip code for this number. This is the only prime factorization for 1,512, and it only points, these two numbers belong to each other. They're exclusive. So that tells us some interesting things about the properties of 1,512 and the number 900. And here you can see we have some of the same factors, right? This one has a 7 where 900 doesn't, and 900 has a 5 where 1,512 doesn't. So that'll help inform finding the greatest common factor and the least common multiple in future lessons. Well, let's put this answer in at WAMAP and see how we do. So here we have 2, shift 6, 3, step to the right, shift 8 for asterisk, and then 3, shift 6, 3, step to the right, shift 8 for an asterisk times 7. And let's see how that does. So you notice before I put in the 7, it said syntax error. It will tell you if what you've written is grammatical, but this is like a spell checker, and a spell checker won't tell you if you've used the wrong word, and it won't tell you if your answer is right. It'll just tell you if it makes sense as far as it can tell. So no rules broken here. We don't know whether or not it's the right answer till we submit this, and if it's green, we're good, we're golden. Okay. So you can get a similar question and work it that way. Ooh, this is a big one. So one nice thing about, let's go ahead and work this one. We'll do 27,000. It's a big number. So we can break this down the same way. 27,000, right? So we can break it down faster, and just using this branching method, let's break it down into like 900. We can go 930, right? 30 and 900, because 30 times 900 will give us 27,000, right? You guys know if we do 3 times 9, that's 27, and then we have 1 0 with the 30 and 2 zeros with the 900. We can put 1, 2, 3 zeros here, and that would be the answer. So we're going to break this down until we get more primes. So 3 and 10, and then 2 and 5. And then on this, the 900 side, let's divide this by 3 and get 300, and then 3 again and get 100. And then now we have to choose either 2 or 5. Do you have a preference? Let's go with 2. I feel like if you use the smallest prime that works, you'll be better organized. So 2 and 50, 2 and 25, and then 5 and 5, right? So then we're all done. And we have 1, 2, 3, 2, so 2 to the third power, and 1, 2, 3, 3's times 3 to the 3's, and 1, 2, 3, 5's, so 5 to the third power. We got 5 times 5 times 5. And these two all multiplied back together, these 3, will give us 27,000. So it's kind of amazing. Unless I made a mistake, of course. This is 8, and this is 27, and this is 125. I think we'll get close. Let's try it and see. So, did I count everything up right? Let's go ahead and see. 2, shift 6, 3, shift 8, 3, shift 6, 3, shift 8, 5, shift 6, 3. Whoa. So what did I forget to do here? I didn't step to the right, did I? So that's an important thing. Let's delete this. Not all of it. There, that much. So you need to step to the right so that you don't stay up in the superscripted area and then hit your asterisk key. Good idea to always hit, always check before you hit enter, and then try not to be teaching a class when you're taking a test, because that can be confusing too. So 2 cubed times 3 cubed times 5 cubed, I'm saying that's equal to 27,000. Let's try it and see. Okay, got that one right. So that's different ways of using this branching method. And then this teacher, Mayer, also uses the other method I introduced the other day, which is like an upside down division box. But if you use the smallest primes at work, generally that will help you organize your problem better. And better organization usually means fewer errors. So you pass the test more often. Anyway, let's see. I think that's about all I had to say about this. So go ahead and try it. You can try a similar problem on your own at WAMAP. And if you get stuck, message me from inside using the message instructor button.